Welcome back. Today we're going to talk about operations with linear functions. Okay, so let's say that I have two linear functions. We have f of x, which is 2x plus 9, and we have g of x, which is 6x minus 1. What this lesson is teaching you how to do is to take those two functions and create a new function such that h of x is equal to the two functions added together. Okay, so this notation, all this means is take whatever f of x is equal to, whatever expression is identical to f of x, and add it to whatever expression is equal to g of x. That's all that's saying. So h of x is actually just going to be 2x plus 9, which is f of x, right? There's your f of x. And you want to add that to 6x minus 1. All right, there's your g of x. Now, when I'm adding them together, I don't actually need parentheses here. So I can actually just drop the parentheses. So I have 2x plus 9 plus 6x minus 1. Well, that's going to be the same thing as, if I combine like terms, I have 8x plus, now 9 minus 1 is going to be 8. Okay, so this new function, h of x, is equal to 8x plus 8. So that's all we're learning today, was we're learning how to take two functions, given two functions, how to create a new function using, we're going to use multiplication and addition and subtraction today. Okay, so this h of x is just equal to 8x plus 8, because it's just taking f of x and adding it to g of x. Okay? All right, let's say that I wanted to create another function, I of x, which is the two functions, but I want to subtract the two functions. Okay, so we have to be a little careful when we do this. We have f of x, which is 2x plus 9, and we want to subtract from it the entire g of x, which is 6x minus 1. Okay, now when we subtract a binomial, we actually have to bring the subtraction through all the terms in the binomial. So the first binomial, so it's equivalent to going keep, change, and bringing this negative into both of them, or changing the signs to their opposite for both terms. So we have 2x plus 9 plus a negative 6x. Notice it was positive 6x before, now it's negative 6x. And since we would subtract a negative 1, we're just going to consider that to be adding 1. Okay, so this I of x is going to be this function. So let's simplify it a little bit here. 2x plus negative 6x is going to be negative 4x. And 9 plus 1 is going to get me 10. Okay. Notice that f of x and g of x are both linear functions, and when I add them together, I get another linear function. And when I subtract them from each other, again, I get another linear function, which is, I can see it's linear because x is only raised to the first power, okay? So there's all those characteristics. X and y are separated by either an equal to sign or addition or subtraction, and all the variables are raised to the first power. So these are both linear, all right? So a characteristic of linear functions is that when you add them together, they get another linear function, and that when you subtract them, they get again, another linear function, all right? Let's say that I wanted to make a new function, h of x, such that it's equal to the first function multiplied by the second function. Okay, now the first function is kind of funny because it's just f of x is equal to 4. Well, that's y is equal to 4, so that, what does that look like? That's a vertical line that hits 4 units above the x-axis. So here's the line y is equal to 4. So that's what this is. So all we're doing for h of x is we're taking literally the number 4, and we're multiplying it by g of x, which is negative 3x plus 2. Okay? Now when we multiply a constant into a binomial, we're going to multiply it into both the terms. So that's equal to negative 12x plus 4 times 2 is 8. So that negative 12x because it's 4 times negative 3x, and then 8 because it's 4 times 2. So that's what h of x is equal to. All right, and so this new function is just the f of x times g of x, or it's this. So notice that when a linear function is multiplied by a constant, you get another linear function.